start recording this workshop. So then later we can publish it for the people who didn't manage to join. QUICKSURFACE is a standalone application for reverse engineering that will allow you to import scan data from any 3D scanner as long as they can export it as a STL mesh. This STL mesh doesn't need to be watertight. It can be noisy. Although in this example, it's pretty good mesh. And then using the tools, simple tools and the workflow, you can convert this into a CAD model that you can export for other applications. What you see on the screen is the imported mesh on the top and then the converted generated CAD model. I was keeping this discussion live until more people join, but now it's the time for me to hand over to our friend and colleague, Victors. It's in your hand, Victors.
Yeah, thank you. Yes, hello everyone. So today we're going to take a look at reverse engineering of this. It's a basically frame for lens for some kind of industrial light. It's basically pretty simple part in general terms. Just takes a bit of time to do the sketches everywhere, but general workflow is super simple and let's say super quick as well. So I guess I'm going to. Are we waiting for some more? Well, maybe. While we're waiting, yes, I will again repeat the same as I'm repeating in every webinar that if you have some ideas about upcoming workshop topics, some parts that you are struggling, or maybe you would like to understand how to reverse engineer them, some different workflows, so please let us know. You can write us email on the support@quicksurface.com, or you can come over to our Facebook group and create some posts there. And after that, we can decide. Probably we can use your part for upcoming online workshop to showcase this. And yeah, just basically we're doing this for your knowledge, to expand your knowledge and skills. And that's why we would like to know what you are struggling with, what you want to know, what you want to learn. This would help me mostly to figure out what to use for next webinars. Not webinars, online workshops, of course.
Before we begin, Victors, there is always the same question: will this file be shared? Yes, we will provide it together with the recording, so you can download and follow the steps that Victors will go through.
Yes, exactly. Of course, we are going to use some scan data that mostly I did by myself or provided by our friends. And we're always talking about that these scan data will be shared across the internet so our users can try it by themselves. And yes, of course, for every online workshop, the scan data will be always shared, and you will be always able to watch the replay of online workshop and try by yourself. Okay, let's start with this, and I'm going to open the scan data. Yeah, so as you can see, it's of course misaligned as always, and we're going just to start with extracting some primitives to align this part according to the system. I guess I'm going to use this part to create the plane, and probably I'm going to try to create a cylinder here. So the coordinate system center is in center of our part. Okay, and I guess the last direction I will create by 2D sketch. Now let's actually we can try one thing. So we have physical options here. And if you don't know yet, we have these two primitives, how to say, selection menu, where you can do the instant fit or just select the interested slice points and tell you want to fit their rectangle or something. So in this case, we don't have actual rectangle or something, and I have idea to try to use outline of this part and fit rectangle there to see how it goes. Maybe it will work pretty fine. What do we see here? Looks pretty much fine, but so according to this, we can see that the part itself isn't actually square. It's a bit off. So, okay, now we won't use this approach. And I'm going to use this segment, the fit line there, and this is going to be x-axis for me. You just click OK. And we can now align by coordinate system, choosing the plane as a top plane. Let's flip it. The secondary feature will be cylinder to define the center of coordinate system, and the last I'm going to use this line, define x-axis. So we can click apply. Take a look how it is. Yes, it looks perfect. So, and from here we can start to recreate actually this part. And I guess I'm going to start with just outline. Okay. And let's start fitting. In this case, that's what's going on. Check primitives, selecting slice points. And it should be an arc, another arc. Let's try to fit line here. This also looks more like huge radius arc. Okay. On this side, okay, as well. There's here also arcs. Okay, so let's say all this is made out of arcs. Back. So now by holding Control and dragging around the endpoints of these arcs, we can intersect them. This. Like that. So, okay, we have like complete profile right now. And I think I will add radius for these corners later, probably. Now we're going just to extrude it. So, and of course we have snapping, so we can decide how far we can go. where we want to go. And we see it's like 4 point something, so let's make it 4.5 millimeters thick. One direction, and yes, let's extrude in this direction as well. And we have similar dimensions, so let's round it up to 1.5. Okay, so we have our first solid right now. And we can take a look at deviation. Oh, it looks pretty fine. Of course, in this case, it's a bit difficult to, let's say, figure out super properly because this part isn't huge. Actually, it's let's say, so as you can see, it's like 8 centimeters by 6 centimeters, so it's pretty small, and it has some powder coating on it. So it's a bit blurred in some places by default from factory. So we will have to deal with this somehow by eyeballing and assuming where is what. And in this case, I'm going to make this more or less as a perfect CAD model. So it means I'm not going to make sketches for each of these cutouts in every corner. I'm going to use mirroring options. And as we are based around the cylinder, so all this is going to be more or less circular patterned. And this will result in more or less perfect CAD model. So as a next step, I guess I'm going to create another profile on the bottom of this part. Let's cut away the biggest chunks of it. Create and clip it so we have better visibility on our object. Another art. And actually, if we want to create this as a more proper, perfect CAD, we can try to mirror these curves to the opposite side, and let's see how this works actually. Oh, well, it's I would say pretty good. So let's go this way, like this. Okay, let's connect corners. This. Probably in this case we have pretty large fillets here. So let's see what do we have here. Hey, millimeters looks perfect. And here. And here. Basically, if somebody doesn't know yet, with holding Control and like coloring two endpoints of arc, we are connecting them. And if we are repeating this on the corner, we're getting fillet. Then you can just type in your dimension that is like assumed by you. Okay, so in this case, I have like inner profile, but I need actually cutting tool, so I will create just a huge rectangle here. This I will flip so I can see everything better. Yeah, this will cover our solid perfectly. So let's extrude it. Direction. I want to snap. I want to snap the first direction to our plane. So basically, even if you don't have enabled snapping, you can drag the arrow and hold your control key, and it will start to snap in different locations. So, and in this case, this is snapped right now to the previously created plane. Okay, this looks good enough right now. So I unhide the solid, select cut. Here we have preview of the resulting solid. Okay. This looks good right now. Hide the plane again. See what do we need? Oh, probably I should go with chamfer right now. So let's try to make chamfer here. See how it works. Tolerance, and according to tolerance plot map, we need slightly different angle. So let's change it to like maybe 40. Not actually still good. Okay, 3 millimeters and 50 degrees looks pretty decent on the largest surfaces. But yeah, as I said, this is powder coated part, so we can see the deviation in different zones are like completely different, and so we'll just use like 50 degrees and 3 millimeters.
I'm sorry to interrupt you here, Victor. I just want to highlight the simplicity of use in this case. Although you just made a simple chamfer, everyone can see the advantage, and it is, first of all, the real-time deviation, which actually allows the user to create this without even any knowledge. Why we implemented this is just because me as a normal user, I have no idea how the chamfer should be like. It's just this visual feedback that you receive, and that's why this is so advantageous. There is a question, is there a way to check the angle before guessing? Well, when you say check, it just you can just play, and that's why with this tolerance display, which we integrate or try to integrate in any function of QUICKSURFACE, the user can really visually see what a good result is, and then, like we always speak about design intent, you can decide what the right value should be. It's just this visual feedback that comes to the end user. So I hope I answered this question, but if you want to formulate it differently, please feel free to type it in the Q&A window. Sorry, go on. Yeah.
Yeah. Well, talking about this topic, actually, we have option to like take a look what it should be. You can create just a simple 2D sketch, fit line to this chamfer surface, and fit just another horizontal line, and you can understand. So it's like 50 degrees. This is a simple way how you can quickly check, and of course, based on our live deviation, you can just play around and find it. At this moment, it's like not okay. I can't call it not simple. It is simple, but we have better approaches coming in future. So this is going to be more fun. Okay, so let's continue with what we can continue. Okay, we have a solid, and we have previously created cylinder. Let's see. Yeah, let's start some. Let's do some more cutting here. Let's create this first. We cut out in the middle. So in this case, actually, we have perfect center, and we can use this to create the radius of this arc. And here we can always use Control button, and you see it just snaps to the slice points, which is super comfortable in many cases. I guess for now I'm just going to leave the same value that we have raw from our scan data and not waste time for this, so we can cover some more workflow actually, and I'll just proceed with this. Good. Bring back our solid again. Cut. Okay. So we have our mixed cutout done. Okay, at this moment, probably I want to use Blender to create a sketch for revolve. With it, and I want to create the step on the bottom side of it. This should be horizontal. Well, probably if this is a casted part, probably here is some draft. So I'm just going to keep it as it is. Connect these two lines. This and this time I'm going to make a revolved surface. Let's hide our cylinder. Let's bring back our solid side mesh. So in this case, we can just trim these two. So basically you have two options. You can make the closed profile and revolve as a solid, and then choose the cut feature in the revolve menu. Or you can make a surface and use this surface to trim out the same geometry, and result will be absolutely the same. Just how it's more comfortable for you. Okay, we have this part done, and at this moment we can add this little bump back here. Let's create another sketch. Let's say this is the circle. Let's extrude this. So in this case, I'm going to hide the mesh by holding Control, snapping to this surface, and here we can just extrude it more and use combine option. We're instantly back at our solid, so we don't have actually to go into secondary menu basically you can skip this. Say this is a solid, so we have like two solids. Then you can select these and say I want to combine them for the same result, but more actions needed, more clicks. And let's proceed with okay, let's make some. I guess in this moment I could make some mounting points. So let's go to the sketch again. Say this height, I like this here. So now let's use this one. And as I said, we are going to make it as a more or less perfect CAD model. Let's just mirror it and see how it looks like. Okay, so here you actually can see that, well, the scan data doesn't remind absolutely perfect CAD model.
Sorry, there is a question, Victor's.
Okay.
How did you select the surface for the last extruded surface to be the object you are cutting? It was a bit fast, and I always have trouble with the cut function. So can you just go back and try to explain these steps? Thank you.
Okay, so let's delete everything, combine. So on this side, but the question was how I limited extrusion, right? Actually, I can repeat.
Oh, how did you select it for cutting?
Okay.
And trimmed.
Okay, so now we have our sketch. Let's do it different. Normally, you draw your sketch here. Then you click extrude or revolve or something. At this point, you select how far you want to extrude this by holding Control and mapping to this top surface. This just eyeballing, I see that it intersects the next surface like this, so I like it here. And now you can choose what you want this extrusion to be. New solid, or you want to combine it, or you want to cut it from the visible solid. So basically, for these options to work, combine and cut, you have to have visible solid that is intersected with your extrusion. Otherwise, it won't work. Well, basically, if you just disable this one, you will click combine, and it will result as a different solid because it doesn't see any solids that it can be combined to.
This is an option. This is an option in extrude that by default you can create a new solid. The advantage is that you save one step. The more professional you become, you want to have less steps in this feature tree. One option is you just press OK, a normal workflow, it's a solid, and then you decide what you want. Do you want to cut it or combine it with an explicit new operation? But what Victor shows here is just two functions in one. I do create my extrude, and then I decide what I want to do. This is a common practice in many CAD packages, and it's not something unusual.
Yes, exactly.
Okay, I hope we answered this question. So sorry about this interruption, but you can carry on.
So let's get back to these. Selecting the slice points. First, at this moment, it's up to user how you want to create your model. You want to create it based just on scan data. So how good is the scan data and how good is the fitment of like these mounting points or something. And you want to follow just the scan data, or you want to create this by logical CAD. So it's just like personal preference, or probably some requests from your customers. So some customers just want to stick to the scan data because they think the scan data is perfect and part is perfect. So okay, we can let them do that. So enable snapping, and well, as you can see here also on this side, we see nice green deviation in this sort of flat surface, and here we can see that one side is good and another side is it's like bulging. So I'm going to choose something average as it is right now, and again, cut function. Okay, perfect. And at this moment, let's make another sketch. Let's say I want outline of this mesh. Create, because I want to complete these mounting points. As you can see, the scan data is like not that perfect in these deeper areas here. So I'm going to use the solid to take the center point, center axis of this cylindric cut, and just will snap to something logical here. Let's say on average we have diameter of 4.3 or something, from 4 to 0.3, so more or less it might be something like 4.2, so you can actually fit normally their M4 bolt. And let's repeat this. So all other cutouts. Okay, so let's extrude all this again. Again, cut perfectly. We have succeeded with this. This okay, everything is pretty easy with this cylinder cuts and everything. So probably I'm just skipping the upcoming 4 ones, and let's continue with something a little bit more complex. So let's start here. So at this moment, actually, if you take a closer look here, so these 2 pockets are deeper than these, the smaller ones. And you can pretty clearly see this. Here, the section plane goes beyond the scan data already, same as here. Here we're still quite far away. So that means we can't make one sketch for all of them and just do one extrude. But we can take a look which ones are the same depth. So all these outer ones look similar. Let's create the sketch. Let's pick one line, another line. And here again, so based on this mounting point on the cylindrical hole, we see that here we have some curvature as well. So in most cases, if this model was built in like some CAD software and based on some CAD rules, it should be concentric, because this would be the easiest way to actually model it, and well, this would be just logical. And here, yes, we can see that everything aligns pretty good here. So again, I'm going to use the solid and the center of these cutouts. to define new sketch. On this side, we can see that the model itself isn't perfect again, but this is like absolutely common situation. This is like super cheap LED light, and of course they are manufactured in millions and cost like a couple euros or maybe 10 or 15 or 20, but so there is no super perfect like quality control or something, and in this case it's not that important as well. So let's stick to one dimension. Here it's like 12.1 millimeter. So let's use the same dimension here. Okay. So now just extending previously fitted lines like this. And, so let's see what do we have here. Basically, this radius should be based on these cutouts, but if we currently don't have them, we'll just use the simple arc. Same as this here should be an arc as well, yes. So we can also use the arc and not to go on to extract primitives and select some slice points. We can just come over here, select our arc tool, hold Control, snap to one point, snap to, I think it's here, another point, and snap third point. So you see lines perfectly, and we're repeating this on this side as well. So like this. Okay, now we just extend this one. See what happens if we extend this one. Yeah, it should be fine. In this case, of course. I think it's 0.5 maybe. Yeah, it's even less, but yes, here you can see that this actually isn't like complete one radius, so it blends into a straight line on one side and on another side. So probably we can actually simulate the same. So let's try to do this, and let's say telling that we have one line here, we have another line here. So now we want to connect them and apply some radius here like this, and now we can connect these two. And let's see, what do we have right now? 0.5. Okay, we're much closer already. 0.45. Let's assume this is what we need. And of course, on this side, we just extend this line and trim this. We can trim these by the moment as well, like this. Come back here, so we can set some radius on this side as well. 6. Okay. And actually, let's get rid of this one. We're going just to mirror all these entities right now. So selecting all these and this one. By the way, if you want to mirror something, you need a construction line. So just simple line won't work for mirroring. So you have to come over here, say it's construction line, And after that, you can actually mirror your entities. Yeah, I forgot to merge them here. Put some radius. Okay. So selecting again all these, this arc, construction line, mirror. Okay. Where, well, by perfect CAD model, it would look different. So at this point, we have to decide what we actually want to do. Or we want to redraw this sketch here as well, or we're just staying with the perfect CAD. To save some time, I'm going to stay with this so we don't waste our time and just move forward. You actually see how this can be modeled, and I guess there is no point to stay longer for these entities. So let's say here we're going to use 0.5 and 0.8. Like this. So okay, we have like our three boundaries, three closed profiles, and we have the same situation on the other side. So we can create another construction line here, vertical one. Construction line. Select all of this, select the vertical construction line, and mirror to the other side.
There is a question. Do we know what scanner was used for this scan? Generally, it's not we work with all the scanner manufacturers, and it's not our goal to promote or discourage this one or this one. What I would like to say here is that no scanner is perfect. So there are several factors which Victor demonstrates. One is can come from the quality of the actual scanner. There are so many different on the market. The next one is if this is a plastic part, it's already wrong, which obviously Victor shows. And so the last thing is the design intent, which Victor's constantly tried to show. So you need to compromise between all these factors, what do you want to achieve? And as I say, we work with almost all of the scanner manufacturers. We're open for cooperation with anyone. So I don't want really to say which scanner this is. It's just an example, but believe me, even if you pay a lot of money for super accurate scanners, there is no guarantee that you get even better results because simply the surface might be different, the material and so on. So I hope I answered this question. There is another one, Victor's. Let me just go to the deviation mapping. Can you set the range or is it auto-scaled? So you can, if you just cancel this and
yes, I will proceed with this, and then we can discuss the deviation map. Yeah, of course.
Just show them about what is this value that you can adjust. Okay, thank you.
Yeah. Okay, so we have our closed profiles. Let's hit extrude. Let's first hide solid, so we can set the depth of this extrusion. As you can see here, I can use, again, the control button and snap somewhere on the mesh. But at this moment, I don't have this deviation control. Basically here where we have snapping, here you can input the value of the deviation map, this local map. And based on this, so you can try 0.05, apply, and at this moment you can see how much it changes, and depending on how good your scan data is, you can play around with this, and of course how good the initial part was. So this is for this local one.
Sorry to interrupt you here. When we speak about this tolerance that you use, 0.1, 0.05, we've been on the market for many years, and my advice to all of you is don't get too low. If you put 0.01, which is 10 microns, you'll never get the perfect result. So be realistic. Normally, these type of scanners, they The good expectation is something between 20 to 50 microns. Victors is using 0.1 because of the type of the project. 0.1 is good enough. But if you want to be extreme, our recommendation, Victors, is what, 30 to 50 microns, I guess, something like this.
Well, basically, it depends what kind of part they have. If this is some mechanical part, the precision part, then you can go lower. If this is a like mainstream part, I'm typically using 0.1. If this is some, I don't know, rough casting, you will want to use something even more. So it basically depends what kind of parts you are working on and how super close you want to be and how good your scan data is. Because yes, as Costa said, this can be the plastic part, this can be the good mechanical part, this can be some cheap aluminum casting part, and always you will have different deviations. So plus one thing is noise that comes from the scanning itself. Another part is the surface of this part. Third part is the coating. So you can have like um, some kind of paint that will have orange peel, or you can have some plastic paints that will be specifically designed to have some grip there, so it will be even more noisy and things like that. Of course, you have to consider this by yourself and just, yes, don't go too low because mostly all the scanners have some noise. Yes, of course, you can adjust everything in the scanning software so you can smooth it. You can, if you haven't done that there or you just have received the scan data, you can actually smooth everything inside of QUICKSURFACE as well. So you can reduce noise. You can select some portions of your scan data and say, I want this to be like smoother, even more smoother, and so on and so on. So you have a lot of options to do this. So you can see this was with some noise, now it's smooth. So this is up to you how you are working. And question about the scanner itself. So this is fairly small part. And in most cases, for the smaller parts, if you want to get better quality of the sharper corners, edges, and everything, you will want to use some laser scanners. With structured light scanners, it's more difficult to capture small parts and sharper corners, smaller cavities, or like these bores and everything. So just it depends what kind of parts you are scanning. So okay, we can proceed, I guess. So yes, this way we have created these 4 cutouts and we can proceed with the last 4 ones. Great. Here again, we can see that this radius looks super similar to this one. So let's try to recreate this by this circle. Yes, it fits perfectly on this side. Actually, this time it fits perfectly on all the sides. So let's say we have another arc here. And here we're going to use, again, just fitted arc because we don't have any more on this side, so we don't have option to actually find out something. Let's extend this one. Let's extend this one. Name it. This side. Okay, so it's our close profile. Let's try to add the radius here. So it's 0.5. 0.45. Yeah, let's keep it to this value. And here, and 0.5, maybe on 0.6. On this side, this is calculated at, let's say, 1.5. for example. Okay, so this is for this part. Now. Let's put this in a couple parts, because the thing is, basically, when you're creating these slice sketches, you can create like complete sketch for all the cutouts and everything, but at the same moment, you will have many lines that can intersect, and overall, this is just going to have like a lot of dimension balloons where you can see all the dimensions and everything, and one will be in front of other, and so on and so on, and it will be messy, and it's more difficult to obviously see everything at the same time. So the pretty good practice is just to break this workflow in parts. So in this moment, I have created this geometry, so and mirror to that side, so like this. Oops. The other side. This one like this one. Okay, Costa, we will need here some improvement. Okay, at this moment, I'm just going to delete this one. So like this, there again, we have these four. So I'm going to extrude these four from there. Again, cut, of course. And just I'm going to create another sketch for the top and the bottom cutout, just to divide them so we don't have too many entities in one sketch, so you can't accidentally move something or do something, or even if you are creating some geometries, you can, if you are pulling some lines somewhere, for example, if we're creating like art here and you are trying to pull it somewhere further, you can see this starts to snap in some locations, and if you have more entities in your sketch, it can try to snap to your different entities. So at the same moment, you can just mess up everything pretty quickly, and later you can just not spot this at the same moment, and you will have some problems later. So this why probably you want to simplify this, so you create feature by feature in like separate extrude and separate sketch, so everything is visible easily, and you can actually come back at every single feature and sketch of this feature, so you can modify it without any problems. So here we're repeating again the same with this circle. Fitting line, this one is horizontal. Then this side out. Actually, the wrong side. I'll turn this one like this. Okay. So let's fit art here. Okay, at this moment we can see that they don't actually clearly align. So we have like two options what to do here. So we have to change something, obviously. Or, of course, we can try to draw here another line, trim the outside of it, and then just delete this line that we used for trimming. And we can come over. Let's say we can try to add 3-point circle here and snap. No, we don't actually like this approach. So at this moment we can come over. This nice tool, and here it looks good. Oh, just a small workaround of this problem. So let's say we need another arc here. This connect radius 35, let's say, like this. So now we can come over to like this one. No, not yet. We forgot to create the mirror line. This is going to be our mirror line. So again, coming back. Yeah, let's like just these 3 ones. Mirror line, mirror. Oh, and as you can see, this side is even more interesting than we had previously. So this is way far away from the result that we saw on the other side. But well, let's continue with the same. We have radius 1.25. Yes, 1.25. This one we have mirrored, so it's absolutely the same as on the other side. This one is perfectly matching. So we have this one cut out shape done. So let's make horizontal mirroring line. Let's select our sketch, mirror line, mirror again. Perfect. So we have this done. Of course, again, back to the same operation, extrude. Let's snap it. Bring back the solid, cut. Okay. So, and this way, basically, this part is why I told it's simple, because all the actions are repeating. Here and there and again, sketch, extrude, cut, sketch, extrude, cut, sketch, extrude, cut. So this is like beautiful part of like some mechanical parts. So just you have to find the correct place from where you can create sketch and just proceed with it.
Okay, but what you try to show us today is that you generally start from the big chunk of material and then you start cutting until you achieve your results. And this is what we learned, that it's not like a magic button you press and everything. And if you're an engineer, you need to plan, you need to see what you need and how it needs to be done. Also, what I saw is the which is important, which we face every day, is that normally the main idea is you need to create surfaces that intersect or solids that remove materials or add materials, and this is how you actually build your final results. Because I know when you load the file, it's really scary. Oh, how should I start? But hopefully with this tutorial and this workshop, you found something interesting that it's useful for you. At this moment, we probably should stop and we'll open the Q&A session. If there are any questions or anything that you want to ask, feel free. Now it's the moment. We don't want to keep you too long, but I hope you learned something. So we are open for your questions.
And well, if there is no questions currently, I want to mention one thing about this. So you are going to have the scan data and you are going to try to reverse engineer this part. So here you can see actually one thing. As a beginning, I just used outline of the scan data of imperfect cut part. And here you can see in the result. So as all features were mirrored, you can see on this side we have nice little edge around it. For example, here it's already climbing onto chamfer. So basically, I started with non-perfect profile of this part, extruded it, and then I started to build these cutouts like in perfect cut model. And this way I got to this error right here. So if you are building like correct CAD model, like it should be perfectly, then when you're creating outline of this frame, just use one side and then mirror it to the other side. And then you will save yourself from things like this.
Okay, we have a few more questions. Are there other recorded sessions of less engineering-friendly parts? Yes, we upload all of our workshops on our YouTube channel. You can just visit YouTube and search for QUICKSURFACE, and then you can land to our channels with the list, and you can find. Also, we have tutorials, and if you go to our website, also there is a link in the under resources or under the training session. You can find all these things recorded. I hope this answers your question. There is a which one should I choose? QUICKSURFACE Pro or QUICKSURFACE for SolidWorks? Also, if we did several videos for QUICKSURFACE for SolidWorks and QUICKSURFACE Pro. Many people are just wondering what is the difference? Why should I choose one or another? We have answers to these questions as well. And it's very simple. QUICKSURFACE, which you see on the screen, is a standalone. Technically, you don't need SolidWorks. You just create what you see on the screen, you export as a step or IGES, and then you use it. Well, the QUICKSURFACE for SolidWorks is a add-in inside the SolidWorks, which means that a lot of operations that you see today here are implemented by SolidWorks on its own. What we add as a value inside the SolidWorks is all these specifically designed tools for reverse engineering, such as control of the extracting the primitives, also the ability to do this real-time comparison. You can do these freeforms and so on and so on. So both of these software, they have a free trial you can download. And if you're a SolidWorks user, just try the plugin. Which version of the software is this? This is the most recent software that you can download from the website. If you're an existing customer and you have version 6 or 5, if you're under maintenance, you can just get this latest version. But if you purchased this several years ago, you can just contact us to how to upgrade to the latest version, which is QUICKSURFACE 2025. Once the model is being created, is it possible to change? Yes, it's like any CAD package. You can just go and edit the sketch, and you can change diameters, radius, positioning of these holes, and then when you just press OK, everything will be rebuilt. So that's the main idea of the parametric modeling.
Oh yeah, basically you can come over to sketch of your extruded cut, and for example, we have here dimension of 7. Let's say it's going to be 8 right now, and I'm going to just change only this one. Click OK, and it rebuilds automatically. So
yeah,
you can do it this way.
There is a question which is slightly about inspection. If you just show the mesh and press compare, the question is, can we see the deviation map between scan part and the design part? Yes, what you see on the screen is you can put the tolerance, which is your acceptance area. We do very simple color plot. Green is the zero tolerance, which we call it. This is actually what you accept as a good thing, which is in this case plus minus 0.1, and everything above is red, and then below is blue. So can we put annotations? Yes, if you just move the mouse over, Victor, you can just click anywhere on the red area, for example, and then you can get the deviation value of this analysis. Now, don't think this is an inspection software. No, it's not. It doesn't have any GD&T, doesn't have any reporting. It's just quick check of what you have created. Question about if we purchase a QUICKSURFACE Pro, when do we pay maintenance? Now, just to clear about our pricing policy at the moment of doing this video, QUICKSURFACE Pro, if you purchase a license, it's a lifetime license. This means once you buy it, you can use it forever, this specific version, 2025 in this example. But it comes with 1 year maintenance included. This means that if you purchase this license, you're already eligible to get the next version, the next major version. So you technically get 2 versions. Then the maintenance after that is not compulsory. This is not a subscription. This means that after 1 year, you can continue using this software as it is. You can use it for your projects, and if you are happy with this, you can carry on. But if you want to benefit of our developments and the new features that we try to implement based on your input every year, you can purchase a maintenance per year. You can contact us about this, how much it costs. We don't have these hidden fees. And again, I repeat, this is not a subscription. You buy a perpetual license. I hope this answered your question, but if not, just contact us. Is it possible that a rough surface will confuse the magic wand and do not extract properly? Yes, that's the answer. Yes, if you magic wand is a tool based on the curvature, and if you get some noisy data, then you definitely you don't get exactly what you expect. So that's why you need to play with the slider, or you may need to. It's simply based on the curvature, how the curvature changes.
Yes, and we have this cool slider, so you can drag it and you can see how the selection grows, these regions. So this is pretty nice, and you can actually see that.
What I would like to say that we don't try to make a universal segmentation tool, because this is super complex. But for example, if you see now the inner ring, it's visible and you can use it. But the small holes are red, which means the curvature didn't work the same algorithm. So, but when you play with the slider, the different areas, you get the different results. So that's why if you stay focused in one area, you can play with the slider, you extract what you need, then you just zoom into another area that it's needed, and then you play again with the slider. And this is the way you need to extract. Again, when you create the primitives, if you select something and fit a plane, for example, you can just try vectors. Just pick something and fit a plane, and just to make sure that your plane is correctly extracted. That's why you use analysis tools. You can see immediately about the quality. You can put this to 0.10 microns, so you can see, or just make it something like this. Now, what you see here is actually a very good tool to show the imperfection of the manufacturing, how the machine has been working. You see a tendency that one side is in blue, the other one is in red. So this means that this plane has actually been deformed somehow for one or another reason. So I hope this answers your question. Now there is again a question about the auto freeform. If I use auto freeform on a part like this, would diameter of mounting points be changed? Now, this is the really fundamental question. Never use auto freeform on this type of shapes. Auto freeform has amazing added value, but for completely different surfaces. You can watch one of our tutorials or one of our workshops where it's a really add value when you have a combination between a hybrid transition between parametric shapes and casting shape, for example, which otherwise is very difficult to model. And this is Victor just tries the auto surfacing. Auto surfacing creates just a wrap around this mesh, which has no idea what is a hole or what its diameter. This is if you imagine you get a kitchen foil and then you wrap it around the plastic part. This is how the how to freeform works. Okay, so we are already, Victor, so 10 minutes above our planned session, but I hope that everyone enjoyed this. And we'll keep making our workshop. And if you have any ideas or you want to see something more specific, please contact us at support@quicksurface.com, and we'll be happy to show you your part and educate other people. And for now, I'll just leave you, and I wish you a good evening.
Yeah. Thanks everyone for joining. Bye. See you next time.
Bye.